Hey, welcome back to the Namespace podcast for episode 11, part 2 of the solid design principles. Yeah. We had too much info. We couldn't get it all into one episode. So now we're going to finish it off. The much anticipated dependency inversion principle is going to be in this.
And interface segregation. Very important.
But we teased dependency inversion.
We did tease. I mean, we probably referenced both because of the whole idea that these are like all very connected principles. So if you're listening to this part 2 episode and you haven't listened to part 1, you got to listen to both episodes together. That's just how solid works. You have to know all the principles.
For sure.
So there's your homework. You have to listen to both.
I'm Derek. This is my co-host, Jordan. She's going to get us started off with interface segregation.
Yes. So
the only good kind of segregation.
That's true. Sometimes I think of it and I'm like, separation, maybe interface separation. But I mean, that's the idea is you want to have your interfaces, like smaller is better than bigger. So I think like the official, sentence for describing this principle is clients should not have to depend on interfaces. What is the, I don't remember the, I guess, official.
A client should not depend on methods it does not use.
Yes. Methods it does not use. So that's the idea. But in practice, basically the way that I think about it is just, smaller interfaces are better than bigger interfaces. And I do think that this principle, for me, I may have different interpretations of it or like different ways that I think about how it's used just because I use Python all the time, which is like interfaces aren't really a thing.
No, they're more than not a thing. They don't exist.
They don't exist, but there is like the
abstract base class,
and you can raise like the not implemented errors, which people do like to create kind of like a faux interface. But there's nothing in Python where
I do believe there's something in like prototype or typing or something, which is interface. I haven't explored it. I don't know if that's true or not. So there may be something, but I've never used it and you don't have to. Right.
Yeah. It's you definitely don't have to use it. And even if there is a thing, it's like more common to use abstract classes or just raise not implemented errors. So in Python, like you're not usually forced to adhere to any interface, but you still want to. Anyway, so that's the idea is just like, that's what I think of it. Smaller interfaces are better than bigger interfaces. Like if you're trying to define your class so that it will adhere to this interface and you feel like you're kind of breaking a rule or like you're doing something just so that this class can adhere to this interface, you probably have the wrong interface. Like you shouldn't have to work so hard to make your class adhere to an interface. If that's what you're doing, then your abstraction might not be the best abstraction for your use case. And then in that case, like maybe separating out your interface a little bit more is going to be better.
Yeah, it's the general understanding.
Yeah.
So I was actually thinking maybe we could talk about the dreaded diamond, which is the issue that languages like C# and Java have with class inheritance and then how interfaces solve that.
Okay.
And that helps explain the shouldn't depend on methods it does not use kind of stuff.
Yeah, I think I was looking at a picture of that like before we were doing this.
Yeah. Are you familiar with the dreaded diamond?
I'm not really familiar with it, but like I do think I saw a picture of it in this article that I was skimming like 10 minutes ago.
Yeah, and that's really the point of interfaces. They kind of solve this problem, which breaks inheritance in statically typed languages. Your issue is if you have a base class, you have 2 derived classes, but then some other base class that derives, or some other derived class that derives from the other 2s. So it's like base, derived level 1, derived level 2, and the hierarchy creates this little diamond looking thing.
Right.
But then when you have a method in there that exists in both derived level ones, that base class doesn't know which one to use.
Right.
So interfaces help split that apart because interfaces have no implementation. So it's just whichever implementation is there, that's what I use.
Mm-hmm. Yeah. I mean, like, I guess, and then Python instead of having interfaces has its own idea where it's like, I guess if both derived classes have the same method, it will inherit the one that's listed first. Like it has a syntactical way of handling it.
Yeah. It's called the method resolution order.
Yeah.
I don't know the entire thing off the top of my head. It is very well defined. And yeah, if you're a Python developer, you should probably understand it, but whichever one was listed first in the list of classes that are inherited, that one will be first.
Right. So in other languages though, what happens in that case? Like, are you just, that's why you have interfaces.
Some languages could solve it that way.
Right.
It's pretty intuitive way to solve that. C# and Java have not. It's probably so they don't break, things written in older versions. So
do those languages have multiple inheritance then, or they just don't?
Oh man. Okay. So one has been far too many years since I've written Java. I don't believe C# does.
Right. So
but I've always used interfaces in C#.
Right. You can implement multiple interfaces.
Yeah. And you can do that in any language really.
Right.
But yeah, multiple inheritance of a class. I don't think I've ever actually tried it in C# because I was just taught interface segregation. And so
right. Yeah.
That's just what I did and it made sense and it worked. So I never had to think of something else.
Even in Python, I would always recommend to just not do multiple inheritance. I think it becomes very confusing and convoluted. I'm sure there's use cases where it like just happens to make a lot of sense, but I prefer to use abstract classes or, in some cases, like my team just will raise not implemented errors in something to kind of act as an interface. And to me, like separating out your base classes more in Python, it can be similar to just like separating out and creating more interfaces. So I usually go that route instead of multiple inheritance because I do think that that's like a very convoluted solution that can be like misinterpreted. And there are like, especially if you're on a team that maybe has people that aren't Python developers initially and they come from other languages, it's like, I think multiple inheritance is just too confusing. Too hard to follow.
I've seen it abused more than I've seen it done properly.
Yeah.
And the way I've seen it abused is people create some class called this thing mixins, and then they drop those mixins into a class. So if you think of a REST framework, it's actually kind of cool because they're like, oh, this is the auth mixin. And this is actually probably a pretty decent use of it. You drop an auth mixin in there, you call auth and like initialize if we're talking Tornado. And because it has the auth mixin, it has all the logic for doing authentication, authorization. It could, accept a JWT or something.
Right.
Like that would actually be a decent use for it.
That does make sense.
The way I've seen it used is, oh, hey, this is the base test class mixin, and they drop it in and it injects a bunch of random tests into everything. And then you're like running your unit tests and all of a sudden it's like, oh yeah, look, these things are here. I'm like, where did those 4 to 6 tests come from?
Yeah.
And then you're looking because it's saying like this test class, this test function, and they're not there. And because the base test class mixin is actually defined in some higher more generic module, you just have to know like, okay, well, let's go start looking through all of those things until you find it. And then you manually do the method resolution order. It's a terrible idea. Don't do it.
Yeah. So it sounds like in that case, what's happening is you're creating a class that just randomly now all of a sudden has so much functionality that it doesn't need. And maybe like just a bunch of responsibilities that it doesn't need also. That's kind of what what I was saying in the single responsibility principle, whenever you're inheriting from a class and you just have now all these public methods in some subclass that aren't actually needed, To me, that's just messy. Like even if those methods aren't defined in that subclass, if you're inheriting all of this logic that you're not using, to me, that's like a bad abstraction.
That's exactly what it is. It's a bad abstraction.
Yeah. So I guess what else can we talk about in terms of the interface segregation principle? Like, well,
okay. So I have a bit of a disagreement with most people who explain interface segregation. They say that you need to split up your interface and smaller is better, or more interfaces is better than fewer.
Yeah.
And I get it. It's like, okay, if you're going to follow that advice, it's not terrible, but it can also cause some confusion.
Right.
So the example I used in my article was the, was it upload and download functions? Yeah.
I can upload, I can download.
Yeah. So if you have an interface that's I can upload and the one that's I can download, but then you have something that needs to do both. If in a language like C# and Java, you're going to have to say whatever type, and interfaces can be put there as the type. Mm-hmm. And that just guarantees it's depending on those methods. Mm-hmm. But when you have something that needs both, you can't specify a I can upload and an I can download. So then you either have to depend on the concrete version. In my example was the FTP client, mm-hmm. or you have to create a third interface called FTP client that it implements I can upload and I can download.
Wait, so why do you have to make this third one?
Because in a function call, you're going to say, I'm expecting parameter 1 to be a I can upload. Mm-hmm. And whatever is passed there needs to have the upload call to it. But mm-hmm. if that method is like a handshake and it hands a file to a server and then picks one up to make sure the handshake works, you can't just say I can upload, because then somebody can pass something in that does not have I can download.
Oh,
so to guarantee that it has both, you have to have a third interface.
Yeah.
Or you have to depend on the concrete class that implements it, but then you're destroying your flexibility, and that's actually a violation of dependency inversion. Mm-hmm. So you already touched on it when you said the example you're talking about. You said it was a bad abstraction. So I tell people that the interface segregation is more similar to the I in CLI or API. Mm-hmm. It's about striking the right balance for your interface. Like at some point too small or super small is too small. If you have an interface, every single interface only has a single function. You're then going to get a bunch of these that then have a bunch that implement a bunch of others, and it becomes hard to maintain. Yeah. So it's all about finding the right abstraction that, the semantics of talking about it and the conceptual things all kind of line up. Mm-hmm. And your abstraction then has a single responsibility. Yeah. And then it ties right back into the rest of the solid design principles. Yeah. So that's my advice, is think of it more as, how is this thing going to be used, and does it make sense for it to be used this way? You don't want to cut it up more than that, because you're making your life difficult, and you don't want to cut it up less than that, because then you're bloating it and you're violating solid design principles. Something that I wish I could say, here's the hard, fast rule for, but you're going to have to take it one abstraction at a time. Yeah.
Like, if you're making a different interface for each method, that's like, that's no longer useful. Like,
and that's what everybody does when they explain interface segregation.
That's what they do in the examples.
Yeah. If you look at all of them, it breaks it up in, so every interface is a single function, and it's not helping.
It's not problem, useful. Yeah. That's not what interface is.
I didn't do it.
Yeah. I'm glad that you didn't. I mean, cause it's like, if you're looking at an example, and the example is like, obviously made smaller because it's the context of just an example, people end up doing that, but that's not ideal. So I think back around to the idea, if you have a class, then you want it to adhere to an interface, but you're having a hard time figuring out like, how can I make this completely adhere? Like you should never have a hard time making your class adhere to an interface. Like you should, if it doesn't adhere to it, then it just doesn't, and you can change your interfaces or you can change your class. And I think that's kind of the idea, is that like, don't force your code to adhere to interfaces that already exist. You may have to change your abstractions as you add new features, as your problem space changes. But and a lot of times that would be obviously preferable to just continuing to add more logic into your one interface.
Well, you can't add any logic to an interface.
Or not logic.
Responsibilities.
Methods.
Yeah.
So yeah, you don't want to just keep making your interface bigger, is the idea. That like, because I mean, I think about it like on that very like large scale. That's like just don't make your interface too big, but you can also make them too small. And that's the thing that's not addressed enough, I think, online. But yeah, I guess, I
think that covers everything, at least that I wanted to talk about interface segregation.
Yeah. I had another note in here that was like, but I guess this is kind of Python specific, because it's like in Python, since there aren't interfaces, you have, like abstract classes, right? Or base classes that raise not implemented errors. And I was just thinking, like, in general, I think that, just Python wise, if people are trying to separate out like their interfaces too much, you might end up with too many layers of inheritance, because in Python, you're not implementing interfaces, you are inheriting. So just the idea that along the same lines as making sure you find the right abstraction, to not allow yourself to just continue making abstractions that layer on top of each other, because that also becomes convoluted.
Right. And that's also why I got to the interface segregation is more related to the I in CLI and API than it is the interface keyword. Because languages that don't have the interface keyword can still adhere to the principle by finding the right abstraction.
Yeah, exactly.
I think also, I mean, in my experience, the closer you follow the rest of the solid design principles, the easier it is to find the right level of abstraction.
Yeah, exactly.
I think all of you will find that as well. It is also partially a discipline. The more you do it, the better you're going to get at it.
Yeah. Like for this one, it's like if you're not following single responsibility and you have classes that are way too big, then your interfaces are probably too big. But if you're following single responsibility really well and you have those responsibilities really well defined, and your abstractions are good for your classes, then you're probably going to have good abstractions for your interfaces for how you're accessing those classes. It's like, as long as you follow the principles leading up to this point, this one's almost just like did I do everything else correctly up until this point? And if so, this is probably fine.
Yeah.
I don't know.
Could be. It could also be a really good way to untangle a mess. If you haven't done any of the solid design, you probably have bloated classes and things.
Yeah, redefine your interfaces.
Yeah, start off with interfaces, refactor the interfaces out, make sure they go to the right places.
Yeah, that's a good point.
It lets you see what is there, and then how to. It gives you a strategy for backing it out.
Yeah, that's a very good
with minimal risk, and so you could use it that way.
Yeah,
as well.
I like that. That's a smart idea. Yeah. If you're like refactoring some terrible code base,
what you all do, every single one of us.
Yeah, start with your interfaces. Okay, cool. So yeah, dependency inversion is the very last principle. It does, as always, the principles are all intertwined. And so you need well-defined interfaces so that you can inject those into your classes and depend on those rather than depending on concrete classes or objects. You want to depend on these interfaces. So that's the idea with dependency inversion, is to depend on these interfaces and the methods in your interfaces, not the methods in your class. or on your objects.
Right. And I didn't read it. I didn't reread my notes before starting this episode, but I think what the principle, the rule, like officially written out is high level modules and abstractions shouldn't depend on low level details. Mm-hmm. They should both depend on abstractions.
Yeah.
Do we have it written down specifically?
I mean, I have the internet at my leisure. I can.
Yes. I know I have it written down in my article. If you want to go to that. Yeah, if not.
Oh, well, it's on Wikipedia. Perfect. Okay. Very reliable.
Totally.
Okay. High-level modules should not depend on low-level modules. Both should depend on abstractions.
Yeah, that's it. See,
I'm pretty sure that's what you said. I mean, we can fact check.
No, what we're going to do is you're going to edit out all the extra words that I put in there to make me sound like a genius.
Yeah, well...
Hey, at this time I want to plug our YouTube channel because they're getting a real fun show right now because I keep looking like making faces and waving as a camera. And it's just because my daughter's hanging out behind the camera right now.
Yeah.
And so if you've never enjoyed the podcast with video, you should totally visit our YouTube channel, which is namespace_pod.
I typically just search namespace podcast on YouTube and then we're there. I don't know.
And you'll find us.
Yeah.
Ooh, hey, so also... gonna drop this. We're gonna have a website, not a website, a page on a site.
Okay. I don't know. You're dropping this to me.
Yeah, this is news to you too. I am developing a site for kind of all of the various teaching initiatives, and so the Namespace podcast is gonna have its own little section on there.
Very cool.
So
I'm excited to be featured.
We'll have a web page soon.
Yeah,
it's gonna look great.
Well, and we do have our web page that just has all of our podcasts on it.
Mine's not going to be much fancier than that.
Yeah, anyway, you can find all of our, we're like plugging in the middle, but you can find our website at namespace-pod.buzzsprout.com. If you're ever on the go and you want to, you don't have an app. Yeah, you can just check it out on the internet.
On the go.
But yeah.
Okay, so dependency inversion.
We finally found the proper definition. But yeah, dependency inversion is one that makes a lot of sense. I do think that this is the hardest one to refactor to if you show up at a code base and you're not doing dependency inversion. If you are relying on concretions and not abstractions, that it can be difficult because you're going to have to make changes throughout a lot of different places for this to work. But
I'm going to disagree. I think open, closed, and Liz-scobs are harder if you haven't been following them.
Yeah.
But dependency inversion also is the one you can't really do completely. Because if you do dependency inversion like one place... like, okay, now this is cleaner, nicer. What you've done is taken the creation of that object and the little idiosyncrasies around that, and you've just kind of moved it higher. And so it's like, oh yeah, I've cleaned up, my couch by putting all of my junk in my closet. Like, well, now when you open that closet, it's going to be a bit messy.
Yeah, well, eventually you can
eventually you get there.
Yeah.
But as you're cleaning your room, you're just shoving things in the closet, and it's like, okay. The room is clean. Let's go tackle the closet.
Yeah. And it is like a very step-by-step, high effort.
I actually almost always start with dependency inversion.
Really?
Yeah.
I guess, yeah. I think I do agree that open closed is going to be harder in that. I guess it's like you really have to.
Well, once you've broken the open closed principle, you've broken it.
Yeah, you have to really delve into and refactor very specific things within the code that are not very obvious. Like dependency inversion is much more obvious. Open closed, I think you really have to study exactly what's happening a little bit more.
And open close is actually based on time, because you have an initial implementation it's open to extension, closed for change. And those two things happen over time. So if at this point you're following open closed, you break it and you're not following open closed, to actually fix it, you're going to re-break open closed because it's another point in time. And so it's going to there's no undoing it. There's accepting the knock that like, yeah, I'm going to have to fix this. But because what you've exposed from your original change has been sitting in code and leaked out and people have been able to hook onto it and stuff. I mean, it's just like, okay, we're ripping, the cord and everything that's grown into it.
Well, yeah,
it's like roots.
That's why you have to, that's why to completely actually undo it. I mean, I think that you could undo it and you could undo.
It's nasty.
But yeah, it would be, a little bit more difficult to see what you're going to affect by making this change. But then in dependency inversion, I do think it's easier to identify kind of where your changes need to be made and maybe.
So this is the code smell you're looking for when you get into a function, and right there near the top, because we all tend to do this, it's variable equals new and a construction object. Yeah, get rid of that, inject the object instead of constructing it. That's the code smell. That's how you fix it.
Yeah. And then another thought that I had about this was like, whenever you're introducing something new to your project, like something new, a third party library or something, it's a great idea to go ahead and just throw up a facade in front of that third party library or tool, just so that you can more easily, like, you can create your own interface within your team to depend on and not have to depend on anybody else's interface, or I guess like other objects that you're using.
I actually think that comes from the abstraction side of it. I actually had a big fight with an architect over something similar around Redis, where I wrote this client to wrap the Python Redis library, whatever it was, PyRedis, I think. And basically everything was just like a pass through. So it was strict adapter pattern and everything passed through it. It's like, oh, this is great because anytime we need Redis, we can depend on mine. And then it's all uniform. I'm with you. I think it was good because specifically what I was trying to do was catch certain exceptions that if we went with an asynchronous Redis client instead would have changed. And I don't want those dependencies like getting into our code. What we ended up going on, and I think was actually better, was an abstraction that removed the knowledge of Redis. And so we were using it for caching. Yeah. But it was a device online cache. So when devices came online, we cached it and stuff. And so instead of having methods in there like, oh, we want to get and delete and what are the keys and those kinds of things, we had mark online, mark offline, and that called the appropriate Redis stuff underneath. And that can't be reused for anywhere else we wanted to use Redis, but it was a great abstraction of an online offline cache. And that achieved all the other things that we wanted to. It was injectable. It didn't let those exceptions sneak in. And it was just a really good abstraction.
Yeah. Like what I'm thinking about there is it's like if you did have that additional abstraction for just sitting right in front of Redis, then it's like anytime anything is using Redis and you want to change some parameter that you're providing, that because you want all of your interactions with Redis to change in this way. I mean, but
then the question is, what if you don't?
That's what I was going to say. Like that might not be a use case for you if you're doing like some sort of microservice thing. And this is like, you're only using Redis for this very small thing. Sometimes you don't need that, but like a good example I'm thinking of is like logging. If you're calling like the Python logger just all the time, just directly, and then all of a sudden like your team is like, we want to change the way that we're logging. We want to start logging in JSON instead of just sending strings, or we want to start providing this additional parameter to our logs. Well, now you have a dependency inversion problem where you are depending on the Python logger explicitly. I like the idea of, I think that's a good example for if that were abstracted out, then it would be very simple to change that one thing in one place versus changing that one thing in all of the places where you're calling the logger. I guess that's an example of like why dependency inversion is good, but I'm sure
it also helps a ton with unit tests.
Yeah.
Because if you have some dependency that actually works with the database and you want to test a function that depends on results coming in and out of the database, you can actually inject a mock and you can force the conditions you want instead of having to seed the database a bunch.
Yeah.
And that was the first way dependency inversion was ever sold to me. And it solved a really big problem because what I was working on was very dependent on an external API, which had all of its subtleties, and then a MongoDB cluster for queuing. And to actually do all the setup and seed things in the right places, you had 600-700 lines of stuff. And then when somebody's like, oh yeah, if you just mock that and do it this way and invert this dependency, and it shrunk to like 20, I was like, oh my God. And I've done it ever since.
So
you're totally right with what you're saying. Just adding on to it.
Oh yeah, no, for sure. I'm just, I'm trying to wrap my head around it. Cause I'm like, if I don't follow something completely, I'm like worried somebody else probably isn't. So I'm trying to think like, it makes sense that if you can depend on interfaces, it's more obvious in your unit test, what needs to be passed in. You can just implement that interface with a mock and then pass in that mock. But exactly. I think the next step that you were saying about like seeding.
Okay. So think of it this way. You want to run a test. Yeah. And whatever the section of code is going to write some stuff to a database, pull out some values, and then delete something.
Okay.
So to run your test in isolation, that test needs to make sure the thing that your code's going to try to add isn't there already. Yeah. It needs to make sure the things that it's going to pull are there, and it's going to make sure that the thing that needs to be deleted is there.
Yeah.
And that's a whole bunch of just seeding values to a database.
Yeah.
Now, if you make it harder on yourself and you put an API in front of that database, now you have to, and this is going to be a staging instance because we don't test against production, right?
Of course not.
Right. Good. I've seen production tables dropped because of that. Oh
my gosh. I've seen the worst. I've seen so bad.
Right. Well, we're not going to talk about those days. Those days are behind you, Jordan.
Yeah, we don't. I'm probably can't talk about it.
Probably. But okay, so let's stick to what I'm talking about here. Okay. So that's just the issue if you're doing stuff with a database. But if you're part of this ecosystem where you write to an API and that API writes to its database, now you don't even have direct access to seed to a database. So now you have to make a bunch of API calls to do stuff. Mm-hmm. So it's not just as simple as like, oh, truncate this table so I know it's clean. It's, okay, let me tell this API, like list all the things there. Okay, delete all of them now. It's like, you just have tons and tons of code to get you to a state where you're like, okay, now I can run my test because it's a staging server and every single developer that's in middle of work is running tests against staging. Mm-hmm. And so once you mock it, it's just like, oh yeah, I don't have to worry about that. I'll just pretend my API said, yeah, that failed.
Oh, I get it. You're mocking the API that talks to the database.
Exactly.
Oh, okay.
That's the purpose or the point I was trying to make.
Okay.
Dependency inversion is really good for testing because you can send in mocks instead of working with something real.
Yeah. Yeah. No, dependency. Yeah, that's a very good point. I mean, I've talked to, I think it was someone we know from Silence, I guess I won't say names, but we were talking about unit testing in C# and how like pretty much the whole idea is just passing interfaces around and like making sure that you're using interfaces. And so, I mean, I feel like I keep saying this because Python is different, but it's also the same where if you have, if you're passing abstractions around, that's going to be helpful for your testing. That's a good point.
Yeah, 100%.
Okay, cool. Yeah. What else is...
I think we covered the big ones, like what's the code smell, how to fix it, and why is that important? And we've hammered on that.
Yeah,
for quite some
honestly,
time now.
I think that we did dependency inversion and interface segregation really well. Like some of the other ones, like Lizkov's took. Honestly, the ones that we covered yesterday, open closed, or not yesterday, but last time, last week, open closed and Lizkov's are to me the ones that have like a lot more to talk about. Like these two are very straightforward. And
they go hand in hand.
Yeah. So let's see. Do we have any like...
Let's take a question live from the audience.
That would be cool if we could do that.
Maybe someday we can live stream.
Yeah, we can do live sometime. Yeah, I guess we've already talked a lot about how these need to be used together.
100%.
I'm not sure if there's any more info we can say about how we need to use them together.
Is because in this episode we haven't plugged a Pythonic guide to solid design principles. It's an article I wrote that explains these principles very well, and it does it using a single code base and showing how they all work together really, really well. Yeah. So selfish plug of my own, but please go read it. It's out on Dev2. Dev community, but it's Dev.2 is the URL and Dev community is the name. It's great. Gotcha. We'll plug Hacktoberfest because Hacktoberfest is going on right now. I have my 4 PRs in. I'm sure Jordan has hers in. No.
There's like 4 days in and you have your 4 PRs? Yeah. Yeah. You're just like updating readmes? No. I'm just kidding.
No, it's features. Repo.
That's great. Can you just update readmes and still get a t-shirt?
Unfortunately. Okay. So I actually saw somebody tweet out. It's funny. He's a comedy writer that is getting into coding, and he says, "You don't even want to know the vile things I'll do for a t-shirt, but I draw the line at useless readmes or useless readme updates." And I was just like, that's so funny.
Yeah, that's smart. I saw online this year that you can get a t-shirt or plant a tree.
Mm-hmm. Yeah, you get to choose.
I wish you could just do both.
Yeah, no.
I kind of want a t-shirt, but trees are also good.
Right. Can't do it, unfortunately.
Yeah. Did you choose which one?
Not yet. So Monday I'll have gone through my week and they'll have verified and approved my PRs or not.
Yeah. Do you know what you're going to choose? T-shirt or tree?
Probably going to go for the shirt. I don't know.
Yeah. I feel like I would have to get a shirt.
I already have one.
Yeah. You actually wore it in our episode 8.
I did. Yeah, probably. I wear it a lot.
I was just working on editing that one.
Our YouTube viewers will recognize that I am basically dressed by tech conferences.
Yeah.
Right now I have something from SAP. I think it's Open UI 5. I have no idea what it is. Got it at a conference. It's like, cool. Yeah. I like that.
Yeah, it's cool.
It's good stuff.
Man, I'm trying to think. Like we went so fast and tried to hit so many points last episode, hoping that we could finish. But I guess this one's going to be shorter. We only have 2.
Right. Maybe I should have just left my brother at the airport. Yeah, he'll be fine. We'll finish these 2.
Yeah, I mean, he probably would have been fine to just hang out. Airports, you can just hang out as long as you want, really. But yeah, is there anything else?
I mean, I think we're good there.
I think we touched base on all of them, but
what's next? What's going to be our next episode?
That's a good question.
Do you know?
Honestly, let's see. I actually have right here. We can look at the list and maybe.
While you're looking that up, I'm also going to plug our social media. So on the on Twitter, you have namespace_pod is the podcast handle. It follows my personal account. I follow them, but personally, I am tweeting out every day about a open source code base that deserves a star and a PR. I'm calling it my Give Them a Star and a PR initiative. If you want to participate in Hacktoberfest, but you don't know where to start, follow the Namespace podcast on Twitter, and I'll make sure I retweet all of those repositories.
Whoa. Cool.
So that'll at least give Python devs like, where can I go? What's a good repository? What's doing something cool?
Yeah.
So yeah, if you want to be in Hacktoberfest, you should follow us on Twitter.
Yeah. Yeah. And then we have Instagram and Facebook. I don't post as much. I guess I should do something fun like that.
You could try.
I'm bad at social media. Anyway, I'm looking at our list. I think that, honestly, I think an episode on serverless would be pretty cool. Like we already talked about microservices,
Serverless is fun.
Yeah, like I think that would be good. I think it would, because I mean, right now I'm doing only serverless development, like only Docker, only like we use Lambdas, but a lot of times in ways that don't make sense. So we can talk about
we could
talk
just
about
because you're using Docker doesn't mean it's serverless though.
Does it not?
No. Because a container runs on a server. And if you have a server, you're not serverless.
But if you're using Elastic or what, not Elastic.
ECS, Elastic Container Service.
Oh, it is Elastic ECS.
There's still EC2 instances behind it, and those are servers.
So that's not serverless.
Nope.
So we should do an episode on this. We have to do some research.
Yeah, serverless is no servers. Which technically doesn't exist because a Lambda runs on a server.
Well, yeah, exactly.
But it's not your server.
But I thought that...
It's not your server.
I kind of thought that that the way that ECS worked was the same as the way that your Lambdas work, where you're not paying for the server.
No, you still totally do.
Okay.
They're your EC2 instances. You can SSH onto them, all that stuff. We can talk about the differences there. I've not done too much serverless design myself. So maybe we could do like a serverless versus Elastic container. That could be kind of fun.
Yeah, well, now I have to do research.
You can teach me something and I can teach you something, and hopefully y'all learn something too.
Yeah. Well, we always do research before these episodes, and we always learn a lot. And
just kidding, I do my research.
Yeah, I'm the one that like comes up with all the notes and stuff, but we do it together. But yeah, I think serverless would be good. It sounds like I need to look into it some more. I really thought that for ECS, you were only paying for your containers and your auto-scaled containers or whatever.
Oh, I don't know how billing works. Serverless is not about the billing though. It's about it's a lot about billing.
Right. Because I mean, with the Lambdas, it's running on a server, but you're just not billed by the server. I thought that was kind of the idea. Well, we'll have an episode on it. This is like a sneak preview of the types of things. We're going to get to the bottom of this. And
here's the list of what we're going to research.
Yeah. Okay, so yeah, let's do serverless then.
All right, serverless it is.
Cool. Well, yeah, thank you guys so much for listening. Definitely send us an email if we haven't plugged enough yet, namespace.pod at gmail.com. We'd love to hear your ideas about solid design. I do think that this episode, as well as the last episode, just solid in general, is such an important part of development. I would love to receive feedback from you guys on this. And I do think this would be a great episode to revisit, like do another solid revisit if we can get enough commentary or if we come up with new ideas surrounding this. But I do think like I would love to hear people's feedback on the solid stuff.
Yeah, 100%.
It would be really great to hear from you guys. Okay, cool.
I think we're good. All right. Catch you next time.